Hey everybody, welcome to another ATDev Podcast. I'm happy to be joined today by William Emfinger, a technologist and entrepreneur in the AT space. Hey William, how you doing?
Hey, Owen. I'm doing pretty good. Glad we could chat this week, as I was very sick last week.
Yeah, I know. Glad you're feeling better.
Yeah, thanks.
And thank you for agreeing to come on the cast. So yeah, you've been a very invaluable advisor to ATDev for more formally recently, but we've been connected for a couple of years now.
Yeah,
And I would love if you could just give a little intro on your background and how did you get into assistive technology?
sure. Yeah, my background, real quick, my background is I studied engineering at Vanderbilt in Nashville. I did both my undergrad and my graduate degrees there. I did my undergrad was biomedical engineering and electrical engineering. And then I went to grad school and got a PhD in electrical engineering. And it was during my time as an undergrad at Vanderbilt, when I was looking for summer internship, that I got connected because I was a biomedical engineer with a small startup in the AT space that was also based out of Nashville. And it was actually just a random chance thing. Obviously, I was a biomed because I was interested in medical devices and robotics. And some of my school projects in the past had been in that area. My dad was a doctor, my brother was a biomed engineer. So I've been raised in this kind of space. But it was mostly just chance that I got into assistive tech, as opposed to a lot of what happens at Vandy is very medical imaging or other kinds of medical devices, not necessarily AT. But I was put in contact with a man named Mark Richter who had started a small company called Max Mobility out of Nashville in '07, and this was '09. So a couple years after he started, and they did wheelchair mobility. So they were looking at propulsion and biomechanics of manual wheelchair propulsion. And so they brought me on, and I interned with them that summer and made some little sensor devices to try to figure out how we can better measure how people push chairs, and made this little device with an accelerometer and wrote the code to detect when they pushed. And I started that project that summer, and it was going well enough. And it was the earlier version where we actually used a gyroscope, and it was going well enough that he actually asked me to stay on throughout the year. So I ended up working for Max Mobility through the rest of my undergrad career for about 2.5 years till I started grad school in 2011. And yeah, it was really awesome. I got to work day in, day out with manual wheelchair users and kind of learn the challenges of being a manual wheelchair user, because
Right.
humans aren't bioengineered to push as their main method of propulsion. So it's terrible for your shoulders. I got to work on different ways of figuring out how to teach people to push better, so more efficiently. But it was when the funding dried up from NSF and NIH right after the housing crisis that we said we can't do any more funding. We can't do any more funded research into how to teach people to push better. It doesn't really help people anyway. We could only ever get like a 10 to 15% increase. So we said, how can we take these devices we've made to measure how people push, and especially this accelerometer based one that you just stick on the chair? It's this tiny little thing. And can we use that output to drive a motor so that it pushes for them, so that it doesn't injure their shoulder and whatnot? And that became the SmartDrive product, which launched in 2012. Now, we were going under, and Mark didn't really have enough money to pay most of us anymore. So I ended up going to grad school in 2011. It was my plan anyway. I hadn't fully decided I wanted to be AT. And so I went to grad school, did a lot of work in more computer and software modeling, like modeling of algorithms and computer networks, and working on fractionated spacecraft. And it was a lot of fun. And I really enjoyed the space side of that. But Mark ended up giving me a call when I finished grad school and let me know that they hadn't gone under, that the product actually was a success, and I had to come
That's
back.
always nice.
And so it was between going back to Max Mobility, which I love that team and the product we were working on, and it was local, so I knew the cost of living and understood the finances. It could make sense versus heading out to California, which is where I wanted to be, and I wanted to work at NASA. But obviously, NASA isn't in cheap places. Like Pasadena is not a cheap place to live. LA is
No.
not a cheap place to live, and they don't pay well enough that I could pay off my student loans in a time frame that made sense to me. I stuck around, and was fortunate enough to go back, become CTO of Max Mobility. I started out as an intern actually, so that was fun. And eventually, a couple years later, in 20 end of 2017, early 2018, we were acquired by Permobil, and I stayed there managing the R&D lab in our Nashville facility, which is the North American headquarters of Permobil, for another four and a half years till about mid to late 2022.
Wow, that's great. That's so interesting. I love hearing people's stories about how they start working in assistive technology because it can be approached from so many different angles. There's the biomechanics and also the electrical engineering. And it's so interesting how you were able to merge the two together and also entrepreneurship too.
Oh yeah. The thing that I'm very grateful to Mark and the rest of the, it was a small team, about six people at Max Mobility. I'm grateful to them for is I was just a young, dumb, like undergrad engineer. I hadn't actually, when I started at Max Mobility, was when I decided I wanted to become an electrical engineer and not just be biomedical. So I took on that
Oh,
major, but I hadn't actually taken any of the classes yet because it wasn't until the following fall semester that I would start those classes. So I'd just been like teaching myself and like playing around with electronics. And I was grateful to them to be because I came in and I was like, look, I really want to work on electronics. I don't have any formal training. Can you let me just build stuff and help work on these projects, even if I take a little bit longer because I have to learn? And they're like, yeah, that's
right.
fine. And I'm so thankful to them that they gave me that opportunity for sure.
Yeah, that's great. And I think that's really great advice for college students that are interested in assistive technology as a whole is that the community is really welcoming
Mm-hmm.
and always needs more talented, bright engineers or designers or whatever you may be. And so it's worth it, even if you don't have the skills already, it's worth it just to go out and start meeting people and saying that you want to be involved because chances are you'll find someone that's able to find a role for you.
Oh, absolutely. And it's just so nice to be able to like see the results of the work you do actually like helping people. And
Right.
especially again, I was fortunate working in like a lab where we had people come in and we would like train them to push or monitor how they push and get to talk to them and work with them. It was great to actually have them there instead of just like being in a lab somewhere working on something and never interacting with the people whose lives it was affecting.
Yeah, it's very rewarding. And when you're taking technology from a lab and applying it to a solution, I have always enjoyed finding solutions that directly benefit people's lives.
Mhm.
And that's one of the things I really love about working in AT is that you know that your work is ultimately going to benefit someone's life.
Yeah, yeah, for sure. And it's definitely, I don't know, it almost makes it easier to solve the problem because it's easier to like keep the context in your head of what is the real reason I'm working on this. It's not just some like technical marvel and I'm trying to do something that's like really challenging with this piece of electronics or this code or whatever it is. It's, hey, there's an actual need that this thing needs to fill or solve. And that made, I don't know, it for me, it always made it a lot easier to make decisions and like design like or develop the
Right.
code or the product. Hey, it's just there. It just needs to be done. There's a hole that needs to be filled here of this technology. Put it there and let it do the thing it needs to do, and everything else kind
Yeah,
of comes together.
exactly. Yeah, exactly. Yeah, and from my personal perspective, necessity is the mother of invention.
100%.
And for me, as a lifelong wheelchair user, that is really what has driven a lot of the innovations and inventions in my own life that have also shaped what ATDev is doing, finding a gap in robotic physical therapy, for example. I
Okay.
have used my robotic arm on my wheelchair to do range of motion on myself and realizing that could be scaled up to help more people and done more efficiently, and suddenly that turns into a product. So you never
I
know
didn't
where
realize
the
you did that
innovations.
with your robotic arm. I didn't know you did that with that. That's cool.
Yeah, that's where the idea initially came from.
That's awesome. I didn't know that.
Yeah, yeah, I was using it to pick my arms up or move my legs, and I was frustrated that I had to manually control the
Yeah.
arm, and I was like,
I
"Man, it'd
can't
be really
imagine
great."
doing that with that like interface to control each joint. Like,
Yeah, yeah, it's certainly not human level
no.
dexterity, but I'm able to reposition my arms or
Mhm.
legs if I need to.
Yeah, yeah. Do you have you made any like helpful like closest I can think of is like macros or tools to help you do it a little bit
Yeah,
faster?
yeah, the interface for the Jayco Canova arm, when you're using it on your chair,
Mhm.
is relatively limited to
Yeah.
manual input. If you connect it to a computer, you
Uh,
are able
yeah.
to have some of those macros. Then you have to be hooked up to a computer.
Yeah. And you
Um,
don't carry your laptop on your chair, or you don't. I guess you can't yet hook up
no,
your Canova to your
yeah,
phone,
not
right?
anymore. I used to,
Okay.
but wasn't totally practical. I kept running into things.
Oh yeah. And ideally, you keep your laptop like on and charging and useful, but it's gonna kill one of your batteries. Either your laptop's gonna die real quick, or your computer's gonna die pretty quick.
Exactly, yep.
Yeah.
Sitting here in July of 2025, what are some of the emerging technologies that you see transforming mobility solutions?
Oh, that is a very rich question. I especially now there are so many that take for example like everybody loves to talk about AI these days. And
Yeah,
to be clear, it is hugely transformative. But I think that like even what we were just talking about of like control interfaces, like having to manually control your like the Jayco on your chair, like at joint level control, because that's the only way that was that basically I'm not gonna say it was the limit of the technology at the time, because as we know, medical technology is usually like a decade or so behind. But
yeah,
it was like standard practice at the time. And that's not necessary anymore with the level of like speech recognition and task planning and like inspection of the generated plans for sign off from like a user. I think that the use of AI to like dramatically augment how much effort and like cognitive load you have to go through to command and control your arm or your chair or the whole system. That's exciting to me, is where that could
yeah,
take the whole thing. And that's not even getting into like just upgrading the tech on the chair and getting like modern motors. Like axial flux motors are like really awesome brushless motors that are like like light years ahead of the brushed motors on your chair today. And that's not even
right,
talking about batteries, like moving from lead acid to some nice, even just like standard lithium ion, or like some of these new salt batteries that are coming out and solid state batteries. Man, there's just
right,
so much opportunity, so that it's not this giant like 400-pound thing that's like a danger first and foremost, right? Like when that thing gets up to speed, it can do a lot of damage for
right.
you and anyone around you, but also so that it's not limiting where you can go, right?
Yeah, absolutely. Yeah, I think a lot about user interfaces, and I think that yeah, there's so much room for improvement. I heard I forget who was saying it. It might have been Sam Altman or someone, but they're saying that they think user interfaces are largely going to go away in the future, and it will be mostly voice and gesture based, which I think is a little bit wishful thinking, but
Yeah, I
it
don't think I
is,
necessarily agree with that. If only
yeah,
because I don't want my robot or whatever I have talking to me. I
yes,
can read, even like, I love audiobooks, don't get me wrong, but I love reading more because I can read faster and I comprehend written text or images way better than I comprehend any audio
Right.
form.
Yeah, me too. Yeah, I'm much more of a visual learner.
Yeah. But that actually gets at the point that one thing I do think is somewhat right about that, which is that the new age of AI assistance is going to be more about tailoring what you have to you rather than you having to learn or tailor yourself and your behavior to how what you use and how it expects to be used. That's
Right.
the biggest breakthrough that I think is happening right now. And it's the same thing we talked about with the J code, right? Right now you have to learn its convoluted and complex interface to do what should be a simple task is now much longer and much more complex because you have to adapt to it. It doesn't adapt to you. And the same is true for anything else today. You have to adapt to how the phone expects to be used, or your computer, or your web browser expects to be used, right?
Yeah,
And
exactly.
and that's the thing that I hope, especially from an accessibility perspective, can go away or at least be minimized.
Yeah, absolutely. Yeah, it goes back to human-centered design
Mhm.
and designing around the end user's need and bringing the technology to them.
Yeah, 100%. And the other thing that I'm excited by, and I've been fortunate enough to be able to do a little bit of work in the space, is just like making like back. A great example is when we originally developed the push tracker, and from there the SmartDrive. Right, it was accelerometer based, and the only reason we could develop it is because we had been collecting tons of data about how people push chairs, right? And so we could analyze that data ourselves and handcraft algorithms, be like, this is how we think a push should be detected. And that's how it ran for almost a decade, right? From 2012 to about 2019, that's how it ran. It ran our manually crafted algorithms that we basically didn't touch because once we got it working and proved that it was safe and effective, we're like, look, we can't touch this until we can make it significantly better and spend the
Right.
effort to prove safety and effectiveness again. But with AI, you're able to embed more intelligence and adaptability into the underlying algorithms for how these medical devices sense the world, sense the users that they work with, right? And so that they can be more tailored to the specific user. And that's everything from like push detection in a manual wheelchair to like making your environmental sensing around your chair more aware of the environment and understanding like that's a floor, that's a person, that's a dog, all of these things
Yeah.
that like people have been doing with AI and computer vision for now a decade, right? They have the ability to dramatically change how effective and efficient and usable our medical devices and our medical robotics are.
Yeah. Yeah, it's really an exciting time to be in this space. And like we were saying earlier, a lot of these innovations are going to translate directly into improving people's lives.
Mhm.
So it's very exciting.
Oh yeah, yeah, definitely. I That's why I love keeping conversation with people like you, Owen, and like working closely with like assistive tech companies. Is just because I love the opportunity to like at least in some small way be a part of that journey because it's just it I don't know it just it's so rewarding and it's work but it never feels like work just because it like I don't know. I liken it more to playing a video game where I actually get that reward I'm looking for and that like satisfaction and enjoyment from versus just like any standard work in like a normal product. I
Yeah.
enjoy things that like have the chance to change people's lives.
Yeah, I feel the same way. And we're very happy to have you on this journey. And yeah, thank you again for your time today, William, and all your insights. It's very wonderful to hear.
Yeah, thank you for having me, and definitely feel free to reach back out if you ever want to chat again. As you can probably tell, I love talking about this stuff. It just brings me so
Yes.
much energy.
All right. Thanks for listening, everybody, and stay tuned for the next one.